everyone, Mariam this side again. So now I have decided to use these kind of notes to make it easy for you guys to visualize, and for we can save our time and we can learn as much as possible with these fixed points in front of us. So as I said before, that first of all, what is matter? Matter is anything that has a space, that occupies a space and has a mass. Okay, matter has a mass and occupies a space. I hope that's clear. And then there are three states of matter, and these are solids, liquids, and gases. So solids have fixed volume, as you have seen when we see a book, then it has a fixed volume, it has a fixed shape, and it cannot be compressed. Why it cannot be compressed? It's because of the arrangement of atoms. When the atoms are arranged in a manner where there is no space for them, so obviously they cannot be compressed. There is no space for them to move here and there. That's why they cannot be compressed, and that is the same reason they do not flow. And liquid has a fixed volume, okay, but it doesn't have a fixed shape. As you guys have observed, you might have seen water bottles and different kinds of, when we use a conical flask and when we use a measuring cylinder, the shape of the water changes. So obviously liquid does not have a fixed shape and it cannot be compressed because its atoms are slightly together, but like less than solids but more than gases. That's why they cannot be compressed either, and they can flow easily because of the much easier and much laid back arrangement of the atoms. And in gas do not have a fixed volume, they do not have a fixed shape, and since there are molecules and atoms are so far apart from each other that they can compress easily, they can be compressed very very easily, and because of that reason as well, they flow in all directions. And now let's touch upon the very important topic that we need to have a grasp on, is the kinetic particle theory of matter. The theory is very very simple. It just states that all matter, every matter consists of tiny particles that are too small to be directly visible. We cannot see them, but there are particles inside a matter. And these tiny particles are always in a constant state of random motion at varying speeds. Why are they saying varying speeds? Because obviously solids there is a different kind of motion, in liquids there will be a different kind of motion, in gases there will be a different kind of motion. That's why they have used the term of varying speeds. So every particle is in a motion but not necessarily in a same motion. I hope you guys are getting my point. So now we will look at these three states in the light of kinetic particle theory. Okay, so they have given us pictures to visualize the arrangement of atoms. Okay, in solids you can see that they are very tightly packed together. It's a very uniform arrangement of atoms. In liquids there it is less uniform. There are a little disturbed, they are here and there. Okay, they are adjusting to the shape of the cylinder. And in gases there is a different story. It's completely different because these atoms are so far apart from each other and they are in like a continuous random motion. They are just moving here and there. Some of them are in the top of the cylinder, some of them are in the bottom of the cylinder. Okay, so arrangement, as I've said, they are closely packed together in an orderly arrangement. They are a little bit loosely packed and they are very very far apart. And why is it that why is it the reason that they are so closely packed together? The answer is strong attractive forces, high force of attraction. Since there is a high force of attraction, they are closely packed. So you can learn this in a way that when the attraction is high, there is closeness. Okay, so basically whenever the attractive forces are high, they are closely packed together. And since in solid there are strong attractive forces but a little less strong than the solid. That's why they are loosely packed. And in gases, obviously, there are weak attractive forces, and this is the reason why they are so far apart, and in a random arrangement they just do not like each other. They are very less attractive forces. This is the reason they are so far apart. Solids have high density, liquids have high density, but gases have low density. And now let's talk about the motion. How do they move? Obviously, because these three states are so different, then they should have a different kind of motion. Since in solid they are closely packed together and there is no space for moving like with a distance, and there is no space for moving like gases. They are vibrating about its fixed position. Okay, they are vibrating about its fixed position, and we use a special term for this. Okay, we say vibratory motion. You should keep this term in mind, because in our GCSEs and O levels we have to use certain terms when we are answering the question. So this type of motion is called vibratory motion. Since they are very crowded and they are packed together, they do this kind of motion. And in liquids they are sliding over each other. Like you have seen that whenever we have a bottle of water, and when we are shaking it, it has a sliding kind of motion. The liquids and the atoms are like kind of sliding over one another. We can see the water is like moving here and there. I would advise you to look at any liquid closely, then you will get my point. So in this kind in liquid, there we have a particles sliding over one another freely. This is the motion that happens in liquid. And in gases, these are so far apart from each other. They are in their own world. They are moving at high speeds randomly, like these arrows. This is moving in this direction. Oh, it's a very, let me use a different pen. Yeah, so this is moving in this direction, this one is moving in this direction. They just do whatever they want to do. They don't care about anyone else. They are just in their own world, roaming at high speeds. And then they have given us a straight trend that with the movement in the states, like solid, liquid, gases, the energy increasing. In the solid the energy is less, the liquid the energy increases, and gases have the most kind of energy. And now we will move towards changes in state. We have solid, liquid and gas. Basically we're talking about how one state changes into another state. So whenever we're talking about liquid changing into solid, we will have freezing. If solid is changing into liquid, then we will call it melting. Since let's see, if we have a glass of water or a bottle of water, if we keep it in freezer, it will freeze, we will have ice. But if we take ice and we put it in room temperature, then it will melt and it will become water again. Okay, simple. And when we have liquid changing into gas, then it will be called boiling. And if it's gas changing into liquid, then we will call it condensing. Like whenever we are cooking something, let's say you're boiling water for Maggie, you will see different kind of vapors coming out of the pot. So that will be our boiling. And if you want to enhance the flavors, that's a pro tip, that when you're cooking Maggie, in the end you should cover the pot for a few minutes. Okay, for 4 to 5 minutes. Sorry, let's get back to the topic. If you will cover the pot, you will see that after 4 or 5 minutes you will uncover the pot, and you will see that there are tiny water particles. There will be tiny water particles on the on the cover. Okay, on the cover you will see tiny water particles, and these will be our example of condensation, where liquid turns into, oh sorry, gases turns into liquid. The vapors were coming out of the pot, but since you covered them, the vapors, they reached the cover of the pot. Okay, and at that cover they turned into liquid. And when we have solid turning into gas, that happens not very often. It's not something that you would see around yourselves, a solid converting into gas. Can you give me an example? Yes, we can, because you might have seen carbon monoxide ice, I guess, I don't remember. So they turn into gases directly, and if it's gas turning into solid, that is called desublimation. I don't know why they have not written this. So I think this would be enough. We would cover the part 2, like we will discuss these changing of states very closely and in detail in the next part, I guess. So till then, you, if you want these notes, you can message me, and take care. Allah Hafiz.